This is Todd Frazee, and this is the video tutorial on developing the solid model, CAD model, of part number 7312, revision A in Fusion. Okay, with an extrusion, it's going to take up the general dimensions of this exterior profile, and we will probably pick up the center donut shape and make that as one extrusion. So we're going to start off with drawing geometry. Okay, so let's go to Fusion, and first thing we're going to do is we're going to save off an empty file, and we're going to save it as the part number. So it's 7312 REV A, and then you're going to put your first initial and last name. Yours, not mine. And then we're going to start doing a sketch in the front view. And we're going to just use our line command. So we have some sort of chamfer here. Go across to the right. We're going to have another chamfer. We come straight down, another chamfer, line up with this edge. This corner is square. Okay, we have the general shape. Now all your dimensions are wacky and nothing's aligned to origin. Okay, so what we're going to do is we're going to take the horizontal line on the top, and we're going to hold the shift key down and press on origin, and we're going to make that coincident, and we're going to do the same thing with the vertical line. And so now those two lines have to be aligned with origin. Now this bottom line, I happen to draw mine not too level. Yours might already be, but I'm going to put a horizontal relationship on it to make sure that stays horizontal. Okay, next thing is we know this line, and this line are all the same length by selecting the first one, holding the shift key down, and then picking the other two, and then using the equal command. Okay, now they'll all be equal. We also need to put an angle on those. So the distance, the angle between here and the base, according to the drawing, should be 45 degrees. And then we're going to set the dimension of the height. And according to our drawing, it was 320 thousandths. And that should force all of them to be the same size. Now we're going to establish our overall width and height. So we go to the drawing. Our height is 1 inch 710. And our width is 1 inch 360. And so now we should have, at this point, if you expand your sketches, you should have a padlock already. So make sure that you're at that stage before we go any farther. We're going to add the donut in the center, but if you have any issues with this part of the sketch, you want to fix it before it becomes more complicated. Okay, now we're going to draw a rectangle within this space, and we're going to now dimension the width and height of this. So if we go to our drawing, we have 1 inch 14 thousandths to 1 inch 7 thousandths. What we want to do is model this at the middle of that tolerance, so that when we're doing our toolpath, we're starting off at the middle of the tolerance. So if I were to take my handy dandy calculator we're going to take the large number, which is 1.014. We're going to subtract the lower number, 1.007, which gives us a 7/1000ths difference. We're going to divide that by 2, and you're going to add that to the low of the tolerance, so 1.007. So we're going to model this at 1 inch and 10/1000ths and 5/10ths. So we can right click on our calculator there, and we're going to go back to Fusion. And we'll throw that dimension on the height. Control V, paste the number in. Now we're going to go and do the width. Same thing. Okay, we're going to take our height of the tolerance is 0.767 or 764 minus 0.757 gives us a 7/1000 split, divided by 2, add that to the low. Okay, we got 76 and 5/10ths. We're going to copy that. We're going to go back to Fusion. Control V, should have the number. Hit enter, and we've got now at least the size of it. Now we need to locate this in relationship to origin and the rest of the body. So let's go back to our drawing, and it looks like it's 300/1000ths from the left edge and 400/1000ths from the bottom. So between this line and this line, we should have 0.3, and between this horizontal line and the bottom should be 0.4. Okay, so now that rectangle is properly placed. Now this object has fillets. Oftentimes I will put minor fillets in as my last feature, as a model feature. This is critical to the design of this particular part because it matches another part, and it has the same tolerance requirements as these two dimensions on the radiuses or control radiuses. So let's look at our drawing, and we have our 4 times radius is a 202 to 195. Okay, so we're going to do, it should be a 7/1000 split or somewhere in there. 0.202 minus 0.195 divided by 2. We're going to add that to the low, 0.195. We get this number. We're going to copy that. We're going to go back to Fusion, and we're going to create a sketch fillet. We're going to pick on the 2 corners, and we're going to hit Control V to put our number in, and we're going to pick the next one, Control V, our next one, and then our last one. Okay, so we now have our 4 corners that are driven by this dimension here. Fusion set up at a different tolerance setup than our drawing. That's okay. It's rounding up, but our numbers really, when the model's actually created, it'll be correct. Okay, so we're going to make sure we're fully constrained. You got the padlock symbol there. We're going to hit Finish Sketch, and we're going to do an extruded new body, and our distance, and we're going to pick on the inside of the shape like it's a donut, but we're not going to pick in the middle because we want to leave that. And we're going to do a distance of the thickness of the part. So if we go back to our drawing, our part is 3/4 of an inch thick, or 750 thousandths. So 0.75. There we go. Looks kind of like a letter D. Okay, we have the primary shape established. Okay, now we're going to put the fillets on the edges of our part, which we have a 7 times 30 thousandths fillet on each of these corners. So 1, 2, 3, 4, 5, 6, 7 times. So let's go ahead and do that. Go back to the model. We're going to do a fillet feature this time. There are 7 edges. And the size is 0.03. And we get those fillets and we're going to hit OK. Okay, make sure you're saving often. The next thing I'm going to do is I'm going to put this hole in the end. So if we look at the end condition, we have a 251 to 252 hole that goes all the way through, and on the near side it has a 300 thousandths countersink. Okay, so let's go back to Fusion and we're going to model it right on the center of that. Go hole, we're going to do a simple hole, but we're going to use a countersink. Hole type's going to be clear, simple. We're going to not worry about the angle because it's going to go all the way through. The surface is going to go on the face that I just selected, but the location is going to be somewhere else. And the sizes probably aren't going to update. So our diameter is going to be a 0.2515 diameter, and our countersink is a 90 degree, and our countersink diameter is 300 thousandths, and our depth is going to be all the way through, so we're just going to say through all. And now we need to select references of where this hole is going. And again, we only use this when it's a single hole. Otherwise, you're going to prepare a sketch for a pattern ahead of time. Okay, so we're going to select one reference edge, which we want it to be the bottom of the part. Okay, so we're going to pick the bottom of the part, and according to our drawing from the bottom of the part, it is 200 thousandths. So this number is going to be 0.2. And then from the right edge, hand edge, it's half the width of the part. Okay, so the part is 3/4 of an inch, which is 0.750. You can either type 0.750 divided by 2, or you can type 0.375. Okay, and that should locate our hole in the correct place. And then we're going to say OK. Alright, now let's look at the opposite side of the hole. It doesn't say specifically what to do with this side. What we do is we're going to take the general edge break note and put a 10 thou chamfer on there. So, and then we'll do that to this inside, to inside and outside edges as well. But we'll throw that on at the very end. We have two more features to make. We've got a threaded hole that comes in through the side, and another one that intersects this plane here. So let's do the one that goes through the side. Our drawing says it's a 1032 through one wall, and then it has a countersink on the top. Now if we look at what one wall is in our model, it's this face until it fully breaks through into this cavity here. So we're going to go and we're going to go to Hole Wizard, and we're going to switch our hole type to a tapped, and we're going to probably have to calculate a distance. Okay, we're going to pick on the face where we want it, and we're going to change this to anti-unified screw threads is fine. Our size, though, is going to be a number 10. And then we're going to pick the 1032 UNF. It's a right-handed thread. And then we need to put a depth of half the thickness of the part. So 0.375. That way it goes through one wall, but not through the other one. And then our countersink diameter, according to our drawing, is 240 thousandths. Okay, and we've got pretty much everything set. Now we need to set our distances. So we're going to select our first reference to the left edge, and according to our drawing, it is 200 thousandths from one edge and 200 thousandths from the other. So we're going to type in 0.2, and then from the second edge, the bottom, 0.2. Okay, so now, and I hit enter by accident. So there's our threaded hole that goes through one wall. Alright, let's put our last threaded hole, and it's in the middle of this face. If we look at here, with this view BB is what's called an auxiliary view. So it's as if we're looking at the part in a plane that's perpendicular to this BB plane facing this edge. So we're going to put the same size threaded hole in the middle of this face here. Okay, so we're going to go back to Fusion, and we're going to make another hole, and we're going to pick the face we want it on, and all the settings really should be the same as the last one we made, although it looks like the countersink's bigger than it's supposed to be, so 2.24. And we're going to pick our edge references. And so let's see if it allows us to do this from this edge here. According to our drawing, it was 730. .73, and then in the other direction, it's going to be to the side of the part, is 0.375 because it's halfway in between the part. Okay, so that should place that UNF. Okay, we've now successfully modeled the 7312 slide stop, and that's the end of this tutorial. We'll catch you on the next one.